Hi guys, welcome to the tutorial on graphing. Oftentimes in fundamentals chemistry or general chemistry lab, the first experiment that you do is to do a density experiment in which you change volume and mass, and you see how they respond to each other to derive density. So I'm going to give you guys an example of how we do that, and I'm going to go through the equation here, y equals mx plus b, to remind you what these variables actually mean. So if we're looking at it, I want you to pay attention to the y. It's called the dependent variable here, right? So that's exactly what it means, is that y depends on another variable, in this case x, right? So that's usually on the vertical axis, right? So this is where our y, or our dependent variable, is plotted. X is our independent variable and is the horizontal axis, okay? So we change x, we see how y responds to that experimentally, we collect data points. Let's say we get something that looks like this, we plot them on our graph, and then we try to do something called the line of best fit. So I'm going to just do a generic line of best fit here, maybe not the best one, but generically speaking. And what you would do is that you would then, to figure out m, which is the slope of the line, you're going to have to do the rise over the run. So that usually entails that you take 2 points on the line. I'm going to choose this one here, and then you take another point on the line, let's say right here, okay? And it has to be a point on the line. And so this first point would, let's say, be 0, okay? I'm making stuff up, but just you get the idea, right? So this is x1 comma y1. And then the second point, okay, you can choose, again, that you could choose whatever 2 points on the line you want, right? This is going to be, let's pretend that it's 10, 20, okay? So that this is x2 and this is y2. So when you're trying to figure out the slope, notice how we're going to do y2 over here minus y1. So 20 minus 5, and then x2 right here minus x1, which is 10 minus 0. So this is 15 over 10, which is 1.5. Okay, so if this was real data and I did it and I used, graphing paper and all that, my slope of the line would be 1.5 units. Okay, now the y-intercept, guys, when you derive the y-intercept, here's what it really means. It means when x is 0, what is y? And some of y'all will, plug everything in and try to figure out b algebraically. But we usually ask you to figure it out by introspection, by really looking at the line where that crosses your y-axis. So when x is 0, do you see why I conveniently chose 0.1 as the y-intercept? Because I knew I was going to need it anyway. So here, when x is 0, y is 5. So as we solved here, we figured out what m was 1.5. We figured out that b was actually 5. So if we were to write a generalized equation for this, it'll be y equals whatever my m was, 1.5 times x. And in this case, it's going to be plus 5, which is my y-intercept here. So this is how I would write my generalized equation for that, okay? Let us do another example, this time with actual data. Let's pretend that, I want you to construct a graph of mass versus number of Skittles. Here's what the data you collected in the lab was, okay? And you're gonna draw the line of best fit. You're gonna select 2 points on the line of best fit that you drew, and they cannot be data points. You're going to calculate the slope, and you're going to find the y-intercept. And basically, you're going to write a generalized equation, and then you're going to use that equation to figure out the mass of 285 Skittles. So you may ask me, like, why would I bother through this entire process if I can just stick 285 Skittles on a scale and call it a day? Now, that's fine. But guess what, guys? The idea of coming up with a generalized equation is it will allow you to figure out what the mass of 1,000,000 Skittles are. Because think about it, some scales have a mass limit, right? So when, let's say that my scale can really go up to like 60 grams, and I can't go past weighing 25 Skittles, this generalized equation that I came up with from my data points allows me to extrapolate from my original findings because of limitations of my balance in this case, or other instruments. So it's a very, very valuable tool for us to come up with that generalized equation. So let's go ahead and do it. So I'm gonna just draw this line for you. Now guys, when you're doing this by hand, you need graph paper. I know I don't have graph paper, so I'm really kind of winging it here on the computer, but you need to have graph paper, okay? Otherwise, you will not get good accuracy there. So when we say mass versus number of Skittles, this is going to be your title. Mass versus number of Skittles. Okay? And it's very important that you put that title. Now, how do I know what goes on the y-axis and the x-axis here? The word that comes first here is going to be your y-axis. And we like you to write it like this, guys. Mass, and then we want to put the units in grams, okay? And on the y-axis, or sorry, the x-axis is the number of Skittles here. Now that's just a number, so you don't have to put a unit. So if you're taking my class, you'd get a point for this, a point for that, a point for that, okay, right away, because I'm making sure that your graph is telling me what it needs to tell me, right? So the next thing that we do is we come up with we got to plot our data points, right? So we have 4 data points, 1, 2, 3, and 4. So now guys, when you're looking at this, the number of Skittles here, remember this was my X, this is my Y. So I want you to pay attention. Let's come up with a scale for X in this case. If you look at the values of X, the number of Skittles, it looks like it's going by increments of 5. So it's fair to say, okay, let's go by 5s. Now if you had really good graphing paper and you had space, you can go by 1s. The finer your scale is, the more precise your generalized equation is going to be. Cool? So now I'm going to go by 5s. So I'm going to do 5. And see how you guys need to use graph paper? Because like my increments are not even here, right? I mean, I'm really like winging it here, and you don't want to wing it in chemistry, right? When you're doing this, you need actual graph paper, okay? So let's see. Good. So that brought us up to 25. Now let's look at our Y scale here. And I want to ask you something. Just because I went by 5s on the x-axis, does that mean I have to go by 5s on the y-axis? No. You don't have to at all, right? So here, it looks like it's more convenient to maybe go by 10s, right? Now, once you establish that, like you do 10 here, you can't jump from like 10 to 30 or something. You got to keep your scale consistent. So 10, 20, 30, 40, 50, and 60. Okay, notice how I don't have to put the units because I've already established that the units are grams here, okay? Let me make this a little bit nicer so y'all can see, okay? Because I kind of squished it in there, all right? So mass is grams. See that's what the grams are for, right? Because I don't have to write it every single time. All right, now let me plot the points. The first point is going to be 5, 12, so I'm going to go right here. The second point is going to be about 11, 27, so that's right there, roughly. See the graph paper. And then you go 15, and 40, like that. And then last point, point 4 is 25 and a little bit less than 60, so maybe right there. Okay, now that's your data points. Okay, so now we can go on to step 2 to draw the line of best fit. So guys, the line of best fit is really an average of all your points. So when you're drawing it, you want to get a straight edge, and preferably if you have like a clear straight edge, that's the best, okay? That way it allows you to see. Now, I say you need to have an equal number of points above the line as you do below the line, okay? And they need to be like equidistant from that line of best fit. Of course, to the best of your ability as a human being. Of course, a programmable calculator like a graphing one would do a much better job, or Excel would do a much better job. But remember, we're just refreshing on how to do this by hand, okay? So, the line of best fit doesn't necessarily mean that you have to connect all your dots. And I would draw it, guys, so that it intersects, because remember, eventually we have to find the y-intercept. Lost my thought there, the y-intercept. So we need to do that by intersecting the line to the y-axis. So I'm going to kind of rough this up a little bit. And I'm going to say, oh, this will not let me do that. Sorry, my screen won't let me put a ruler and all that at the same time. Okay. So, okay, let me fix that again. I'm going to say, that might be a better one. Okay, so you see how you have like 2 points above the line, 2 points below the line. So, and then they're kind of fairly equidistant right here when you do that. That's what a good line of best fit should be. But again, it does not have to be connecting the dots. Okay, now guys, when you've done that, you need to select 2 points on the line that you just drew. What is the point of drawing the line if you're not going to use it? Do not use data points to come up with your slope. So conveniently, I'm going to go ahead and I'm going to choose this as 0.1 because I need it. It's the y-intercept, right? And then for the second point, I'm going to choose like, so 20 wasn't here. So you know what? I'm going to go ahead and choose 20 and see where that hits the line. And that's my point. And that looks like roughly at what? 48. So 20, 48 there. That's my x2. That's my y2. Now here, my 0.1 conveniently is 0. I just really like to use that as 0.1. It saves me time. So that looks to be, maybe I want to say 13. See, if you had good graph paper, you wouldn't have to guess like that. But we're trying to get the idea across here, okay? So that's my 2 points. This is my x1, and this is my y1. So to calculate the slope, you need y2 minus y1, okay, and x2 minus x1. So y2 here is 48 minus 13, and then we're going to do 20 minus 0. So when we do that, this is going to be what, 35 over 20. Okay, so when you calculate that, this comes out to 1.75. So your M here is 1.75, okay? Now guys, what are we going to do with that slope? The idea is after you calculate the slope, and of course we did that, like see, we went ahead of the game here, and this is my y-intercept b. When x is 0, where does my line hit the y-axis? So when x is 0, what is y? Here it was 13. So that b equals 13. See, I didn't plug it into the equation and backward calculate b, right? I got it from that line of best fit. Now, our generalized equation would then be what, guys? Y equals, let me do that nicer, okay, y equals m, which is 1.75x plus b, which is that right there. Okay, so you see that equation that I just came up with. For x, which is the number of Skittles, that can help me figure out without, let's say that my scale doesn't go past 60 grams, so I can't weigh 285 Skittles, all right? Let's say, hypothetically speaking, right? And then what am I gonna do? I'm gonna go ahead and use my equation here, and then I'm gonna do 285 plus 13, and then you know what? Even though my scale has limits, I can come up with the answer, because that's why what the idea of the generalized equation is that you could use it for anything that your little heart wants. Okay, so if we're gonna round here, this would be 512 grams. So this just helped me determine the mass of 285 Skittles from the generalized equation. So all this work was not in vain. It was meant to help you figure something out that you can't because of a limitation. Okay? Now, you guys will, if you're doing a lab on this, you'll probably do the same thing. Let's review. Make sure you put your titles, okay, here. And when you put, remember, the first word is going to be the word that goes on your y-axis. Put the units, don't forget that. And then here you would put the second word in your title is also going to go here. Plot your data points. Create the line of best fit so that you have an equal number of points above the line as you do below the line, because the line of best fit is really an average of all those data points. Do not simply connect the dots. Draw your line so that it intersects the y-axis. Choose 2 points on the line that you just drew and that are not data points. So there you go. The first one conveniently that's how I do it. Conveniently just use the first point as the y-intercept, because you'll use it later. Choose the second point. Calculate the slope using this equation. Then go ahead and come up with a generalized equation and then use it to solve your problem. I hope this helped you solve your problem, but again, I'm going to say use that graph paper. Don't forget that. All right, until next time, guys.